about this velocity versus time graph. I'm not getting into nitty-gritties of the values. Just analytically think about what it is all about. So if you look into this part, you are in negative velocity, right? So you have some velocity, maybe it is -3, and it becomes 0, and then you turn your, steering and start going towards positive direction. So for some time you went like this, which is -3 point, and then you became 0. You stopped there and you started going back, right? So this is what it represents. If you see, this is a positive slope, okay? So you are, in fact, you are in the fourth quadrant. This is what it demonstrates. So the negative area is your displacement, okay? It's negative. Therefore, so when I draw this graph, and I look into this, what I see is that my, final velocity is 0. My initial velocity is -3. And all this happens in 2 seconds. So I do 0 minus -3, okay? V2 minus V1 divided by 2 is equal to 3 by 2, right? So this is positive slope, this is acceleration, right? And XT graph acceleration is a parabola. Now you have two choices. You could draw it like this, which means your initial velocity is more, and then it reduces. The second way you could do is, you could draw it like this. And I'm just trying to bring it close to reality, which is 2 seconds. Now what this shows is that the slope is increasing. So the slope here is less, the slope here is more. So you're accelerating, so which is, so select this one, do not select this one. Okay, so this is your acceleration, and then you continue with your acceleration, but this time you have changed the direction. So what you get is a positive, displacement, and you have just changed the direction, but you're still here. And this time you're still accelerating, so draw your normal parabola, which is, shown like this. So I don't know whether, we'll be able to make it to this place, but let's try, artificially. So let's say this point is this point. So that's another normal parabola you have. After you have drawn the first parabola, draw another parabola. This is constant velocity. So this is a parabola, by the way, okay? So this is like this, okay? The second graph is this is a parabola, and this also is a parabola, and then you are moving with a constant velocity, which is a straight line for some time. Maybe let's try and use this as a reference, and so it continues to move, and then it decelerates, right? So when it decelerates, you have two choices again. You could draw it like this, and maybe say this is increase in velocity because initial velocity is low, and then it increases. So this represents acceleration. But if you draw it like this, what it shows you is the initial velocity high, and the velocity shows you retardation, right? So this is what is happening to the body, right? The slope is negative for VT. So essentially, you have uniform acceleration, uniform deceleration, and a small part which is straight line in the XT, which represents uniform velocity. So this is your uniform velocity, this is your uniform acceleration, this is your uniform deceleration. So the concepts we used were, parabolic, uniform acceleration, it's accelerating, so increase the slope first, and then draw your normal, and then you reach, there some time which is equivalent of this, and you could find the actual values, and decide how long will you take this. Maybe the parabola goes slightly up, and then maybe, because I think this was 2 seconds and -3, and this was 2 seconds and 4. So the question is wrong. This cannot be a straight line. The slope should have been a bit different. But anyway, so this is, this is another one, and then you have a constant uniform velocity followed by, small, so to say, a deceleration. So that's how you culminate this problem and draw the XT graph. Now, in the limited space we have, let's try and work out the AT graph, okay? So what you have is acceleration from 0 to 4 seconds. So what you get is a constant acceleration, which is, for 4 seconds. Then your acceleration becomes 0, and then you can find the slope of this graph, whatever it is, and show the slope of the graph with respect to time in the bottom direction. Maybe the slope is very high, so you could show the negative acceleration here. So you maybe, I'm just representing it, you could actually calculate the V delta V by T in this part of the world, and get a negative. So you will get a AT graph, which is like this. So one was your position time graph. The second is your AT time graph. I hope this helps. This is the time I had to solve this. Just bear with me. I don't have graphs, so I just done it quickly. Thank you.